Good morning. Welcome to TMMS Productions. Today, our topic of study is geometric progression, which is part of ICSE syllabus. In the last few videos, we have seen what an arithmetic progression is. Now, when in a sequence, two numbers, consecutive numbers, have a definite difference between them, we call them as arithmetic progression. Now, in geometric progression, we also have a sequence of numbers. So the sequence of numbers could be like the first one over here, 2, 6, 18, 54, dot, dot, dot. Now when we have a sequence of numbers, this also could be written as 2 plus 6 plus 18 plus 54 plus dot dot dot. Now when you write it like this, it becomes a series, and understand that in order to see the pattern, we have to look at the first term. The first term is 2, so I shall write A1 is equal to 2. The second term is 6, which is plus 6. So I'll write A2 equal to 6. Now, what is the pattern 2 and 6? If we say that 2 plus 4 equal to 6, then 6 plus 4, this should be 10, but it is not so. So now let us see, how do we get 6 from 2? If you multiply 2 by 3, you will get 6. So 2 into 3 gives you 6. 6 into 3 gives you 18. 18 into 3 gives you 54. Which means now if I divide the second term by first term, let us start on that. We will say A2 upon A1, that is second term upon first term, means 6, which is the second term, upon 2, which is the first term. So 6 upon 2 is equal to 3. Let us look at third term upon the second term. So A3 upon A2 will be equal to 18 upon 6, which is again equal to 3. Shall we do this as well? A4 upon A3. So A4 is the fourth term, 54, upon A3, which is the third term, which is 18, and that is also equal to 3. So we see that here the ratio between the consecutive terms is the same, it is constant. Can we see that? And we see the pattern that A2 upon A1 is equal to A3 upon A2 is equal to A4 upon A3. And so we will say that the common ratio is denoted by R, and that is equal to constant. And what is that constant number? That constant number is 3. If we have a group of numbers which will have the same ratio between the consecutive two numbers of the sequence, then that sequence of numbers forms geometric progression. Now look at these two examples. Question 2, 8, 16, 32, 64, dot, dot, dot. And third one is 18, 24, 32, 48, dot, dot, dot. Now pause the video and check whether these two are in geometric progression. How will you check that? A2 upon A1, then A3 upon A2 for both. Now, let us check it out for our second question. Our A1 is 8, A2 is 16, A3 is 32, and A4 is 64. So, we will write over here A2 upon A1 will be 16 upon 8, which is equal to 2, which I'll call as R1. Then I'll say R2 equal to, I'll take A3 and that will be divided by A2, and that is 32 upon 16, which is again 2. So can you see your R1 and R2, both of them are 2, which is the same, and so we will say that this sequence is in geometric progression. Let us look at the third one. In the third one, you will see this is 24 and this is 18. So A2 upon A1 becomes 24 upon 18, and so you will see 2 will divide. This we will call as R1. Let us call A3 upon A2 as R2. A3 means the third term. A2 becomes the second term. 8 4s, 8 3s. Can we see that? Now R3. What is R3? That will be now A4 upon A3, which is 48 upon 32. Now 8 6s, 8 4s, now this is 3 upon 2. So now you will see R1 is equal to R2, but it is not equal to R3. So this one, second one, is in geometric progression, but this one is not in geometric progression. Why? Since R1 is equal to R2 but not equal to R3, and so it is not a geometric progression, so it is not a GP. So now if we want to come to the definite pattern or rule for the general term, we will talk about A, which is the first term, and we will talk about R, which is the common ratio. What is R? Common ratio. So if we say our first term A1 is A, then our second term will be AR, because A multiplied by the common ratio will give us the second term. Now A3, remember A3 upon A2 is R. So if A3 upon A2 is equal to R, then A3 will be equal to R multiplied by A2. So what is our A2? It is AR. So A3 will be AR square. What will be our A4? That is the fourth term. It will be A3 multiplied by common ratio, which is R. So it becomes AR cube. Now if you observe the pattern, if it is the fourth term, I have AR but the power is 3. If it is the third term, I have power of R as 2. Now what is the connection between these two? 4 minus 1 gives you 3. So if I have AN, which is the nth term, won't I be able to say that it is AR, but now power of R will be 1 less than this, just like 4 minus 1 was 3, 3 minus 1 was 2, 2 minus 1 is 1. Can you see that? So here it becomes nth term as AR to the power n minus 1. And that is our first formula. What does our first formula tell us? It tells us the nth term of the geometric progression. Some other formulas which will be very helpful for us to solve questions on geometric progression are Sn, which means the sum of n terms. Now Sn has two formulas. One is when the common ratio is less than 1, and the other one, this one, is when the common ratio is greater than 1. If the common ratio is less than 1, then Sn is A, which is the first term, into bracket 1 minus r to the power n upon 1 minus r. And if r is greater than 1, then Sn is equal to A into bracket r to the power n minus 1 upon r minus 1. And also the third formula is A into L. A is the first term, L is the last term. So A into L is equal to nth term multiplied by nth last term. Like for example, the first term multiplied by the last term. So if first and the last term are mentioned, we could use first term multiplied by the last term will be equal to the nth term from the beginning multiplied by nth term from the end. Which means I could take fifth term multiplied by fifth last term, or the second term multiplied by second last term, or 10th term and the 10th last term. So A into L will be nth term multiplied by nth last term. Hope you have understood the concept and the basic formulas. Thank you for watching.